Today I want to solve some problems that will involve adding with three-digit numbers, and I want to solve those using base 10 blocks to help reinforce what students learned in prior grades. So I want to start by adding 142 plus 237, and I'm going to build that with base 10 blocks. So for 142 I need 100, 4 tens. 4 tens is 10, 20, 30, 40, and 2 ones. So I have 142. Then I also want to build 237. So I have 1 200s, 3 tens, 1, 2, 3 tens is 10, 20, 30, and then I have 7 ones. Here's 1, 2, 3, 4, 5, 6, 7 ones. And since I'm adding, I want to reinforce the concept of joining these two sets together. I want to join 142 with 237. So I want to join all the hundreds together. I want to join all the tens together. And I want to join all the ones together to see what my answer will be. So how many hundreds do I have? I have 3 hundreds. 1, 2, 3 hundreds. How many tens do I have? I have 1, 2, 3, 4, 5, 6, 7 tens. And then how many ones do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 ones. So I have my answer here because I've joined 142 and 237. So I know that I have, if I write this in expanded form, I had 100 plus 40 plus 2, and I was joining 2 hundreds plus 30, or 3 tens, plus 7. So now I have 300 plus, I have 7 tens now. Here's my 7 tens. 40 plus 30 is 70, or 7 tens. And I joined my units. 2 plus 7 is 9. So this ties back to my expanded form. I can put my number together. 300 plus 70 plus 9 is 379. And I can prove that by going back and counting my base 10 blocks, if that would help me with my understanding. 379. 379. Now let's see what that's going to look like with one regrouping involved. So I still want to build my numbers. 100, 5 tens, 1, 2, 3, 4, 5 tens is equal to 50, 10, 20, 30, 40, 50, and 8 ones. 2, 4, 6, 8 ones. So I have 158, and I'm joining 117. So I need 100, 110, and 7 ones. 1, 2, 3, 4, 5, 6, 7. So I've built my two numbers, and I want to look at how to join those together. Let's write them in expanded form so we see here's the 158 and here's the 117. So 158 is 100, here's my 100, plus 50, here's my 50, plus 8, here's my 8. And I'm doing that so that I can help students see where did these base 10 blocks come from, where did these numbers come from, and then I can help them understand when regrouping comes along why I have too many of a certain place value. So then I also have 100 plus 110, which is 10, plus 7 ones. So when I join them together, remember I'm joining the hundreds together, I'm joining the tens all together, and I'm joining the ones all together. So I'm going to start with the ones, and I can see I have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have way too many. I have 15 ones. And I would ask students, Can I have 15 in the ones column if I'm thinking about place value? I can only have up to 9 in that place. Once I put 10 together, what has to happen to that? If it's a 10, it has to move to the tens place. So we're shifting. That's that shifting conversation we've had. So if I group these and I say, here is a set of 10, and then I have 5 more. Well, now I understand why I have too much for the ones place, and I understand why I need to shift a 10 over. So this set of 10 needs to move over and belong to these because it's a 10. So I have 5 here, and then now instead of 1, 2, 3, 4, 5, 6, instead of 6 tens, I now have 7 tens because I have another set of 10. So let's see what that would look like. When I first use my expanded sums to solve this, if I write this down, I have 2 hundreds plus 50 plus 10 is 60, and 8 plus 7 is 15. Well, we decided that 10 in 15 has to go to the tens place. So this is where we talked about funny numbers. This is a funny way to write this number. It's not making sense to me right now because I have too much in the ones place. But if I shift this 10 here, this is my number bond, right, of 10 and 5. This 10 has to come live in the tens place. Now I know I have still 200, that's the same, but I have 7 groups of 10. 70, here's my 70, and then I have 5 left over. So I have 275. Now, if I want to make sure students understand that that number is the same, can I count my place value blocks? Of course I can. 200, 10, 20, 30, 40, 50, 60, and if I need to, I can count these by ones to prove to myself that this is a 10. So I could say 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. Oh good, I do have 70 in the tens place. And then I have 1, 2, 3, 4, 5 in the ones place. So what happens when I have to regroup twice? Let's see what that would look like. So I started off by building my base 10 models. I have 100, 67, and 145. And I'm going to write these in expanded form for my students to be able to see where did these numbers come from when we're solving. Okay, so I'm going to join the hundreds together. I have 100 here and 100 here. I'm joining those together. I have 6 tens here and 4 tens here. I'm joining those together. I have 7 ones here and I have 5 ones here, and I'm joining those together. And I'm just grouping them like this so that you can see them on the screen. Not that I would necessarily do it like this with students. I would make sure I had my hundreds, my tens, and then my ones to the side over here, but you wouldn't be able to see them very well. So now that I have them joined together, I can see that I have 2 hundreds. How many tens do I have? Well, let's count them. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tens. Let's count by tens to understand what that's equal to. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I have 10 tens or 100. And then I can count my ones. Let's spread them out. I have 2, 4, 6, 8, 10, 12. I have 12 ones. But 200, 100, 12 is a funny number. That doesn't make sense to me when I think about how these numbers work. So if I think about this as a number bond of 10 and 2, now I see instead of just 10 tens, I actually have 11 tens. So this is 11 tens. So let's write that down. I have 200 plus 110, or 11 tens plus 2. That's still a funny number to me. I can't read 200 plus 110 plus 2 as a number in expanded form. It's kind of funny to me. But if I look at all these tens that I have, I should see that I also have 100 here. So if I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, I need to shift 100 to the hundreds place. I need to see this as 100 plus 10 as my number bond. This 100 is the same size as this 100. It's the same value. So this 100 needs to join with these hundreds. So here are my hundreds. So now I have 300 plus 10 plus 2. And that looks like a regular expanded form to me that would just work out easily. 300, 10, and 2 is 312. And if I wanted my students to count this to prove it, I could do that. I could say 100, 200, 210, 220, 230, 240, 250, 260, 270, 280, 290, 300, 301, 2, 3, 4, 5, 6, 7, 8, 9, 310, 311, 312. So I can still prove what's happening with my base 10 blocks. So let's look at how we move this toward the algorithm. So if I take my expanded forms that I wrote down, I'm going to have to move that because you can't see it. Now I think you can see it. And I write them this way. Now I can solve. 7 and 5 is 12. I'm going to just keep bringing down my plus signs so that I can see expanded form. 60 plus 40 is 100. 100 plus 100 is 200. Oh, look at that. That matches what we did exactly. And then we figured out that we needed to make this be a number bond of 10 and 2 so that these 10s could join these 10s. And I had 200 plus 110 plus 2. And that matched what we did here. Now I need this number bond of hundreds and tens. So 100 plus 10. And then we had 300 plus 10 plus 2, which matched this step. So you can see how each part of doing this with the base 10 blocks also works through the algorithm as well, so that they can see. And then eventually we want them to understand the connection. 7 plus 5 is 12. Oh, I can't put 12 here. I can only put the ones. So my 10 shifts over. That's why we have that 10 shifting over when we moved it right here. That's what this 1 is. They need to understand that's a 10. That's the 10 we moved over. Then I can say 1 plus 6 is 7 tens, plus 4 tens is 11 tens. But wait, 11 tens can't live in the tens place. 1 10 can, and then I need those other 10 tens, or 100, to move to the hundreds place. Then I have 100, 200, 300s. So we can see how we progress through from base 10 blocks to number bonds and expanded sums to the standard algorithm.